2023. This is the calendar. So if you go silence, why are you talking during this video? All right, had to get that in. I did put that's cat meow. All right, everyone, just relax for a second. All right. Oh, I already have a cat student here. Where's IM2 honors? There it is. See if I have anyone on this one. Okay, this calendar exists both in Google Classroom and I put it as a link at the bottom of our Q3 calendar. One way or the other, do the old switcheroo. If you still have not bookmarked my calendar up at the top, that's how I feel about you. All right. Hey, welcome back from spring break. Sorry. All right. Okay. So let's go to the notes. So anyway, find that calendar. Don't really need it for today because everything's been provided for you. All right. Can everyone say quadrilateral? Four-sided figure, quad. All right. But here's one thing. Just what is a diagonal? Oh, please. All right. We're going to draw a lot of diagonals. And actually, maybe get your highlighters out or different colored pens when we mark other drawings. Because actually, we're going to write what the properties are of specific quadrilaterals, and then we're going to mark it with geometry. So it's real basic. You probably had this in grade school, but then I'll tell you how this is going to turn into high school questions, right? And then actually relate to maybe some area questions that we're going to actually move into. Going to have an area day. Okay. Now the next one's a parallelogram. Okay. Then you see, do you have 1 through 4 with some spacing, right? You have 1, 2, 3, 4 in your blank notes. Okay. And then I know you can kind of see through this, but obviously what a parallelogram is, opposite sides are parallel. Well, we're going to mark that as you write that down. Put arrows and arrows. That means parallel. And then I need different arrows or different symbols. So usually we do a double set of arrows. That means a different set of parallel lines. So again, we're going to write with math symbolism. I'm going to change colors. Congruency, then that's little like tick marks. And then I need like 2 tick marks on this one. So that represents the congruency. Maybe underline that and then underline that and right. Well, I'm not going to do that. That looks like it changes the symbol, but you get it. So the 2 arrows mean they're parallel. Doesn't mean they're equal. So you need equal marks, right? Not that you have to do this. It's just good to know kind of stuff. And then opposite angles are congruent. So how do I mark congruent angles? We could do an arc with a tick mark and then an arc with 2 tick marks. So they're not equal consecutively, they're equal across from each other. So that's what opposite means, across. One thing, though, this is written fourth, which should be probably written third. And I do want to stand up here a little bit. I don't know how far this wire will let me. It's a Fattermac, this new screen. I can actually move the screen up and down with my hand here. And I actually was able to erase in the other hour with my elbow. Let's see if that happens. No, there we go. Isn't that wild? I don't know why that's happening. Let's see if I can get it to go. There it goes. There, good. So now you can see the next 2. I erased with my elbow. All right. So the consecutive angles, that's what I wanted to get to. You could write that third or fourth. Couldn't anyone? Care less. Doesn't matter. Consecutive angles are supplementary. It's because they are same side interior angle measures cut by a transversal. These 2 lines are parallel. I just said that theorem terribly. When 2 parallel lines are cut by a transversal, same side, I think my elbow hit the screen. That's why that moved. Same side interior angles are supplementary. I almost said congruent, which I did not. Supplementary. So opposite angles are congruent. Same side or consecutive angles are supplementary all the way around. And then the here we go. I got to write this. Okay, I'll probably write this in blue. Here come the diagonals. And I did spell that one right there. The diagonals. This is why we had to define what a diagonal is. Now, obviously, this is what I mean about, assuming some stuff. Is that diagonal equal to this diagonal if I got a ruler? Yes or no? Yes or no? Do you think they're equal when this is so slanted? The second one I drew, everyone should theorize that second one's longer than the first one if I would have got a measurement tool on there. So they're not equal, But what they are is they bisect each other. I already have 1 and 2 marks denoting some equal sides. Now I need 3 marks for that. I don't like how I did that. Let me just go back, and then do one more tick mark. Little out of practice after spring break. And then this one needs maybe 4 marks and 4 marks. So they bisect each other, but they're not equal to each other. The first one, top left to bottom right, has got to be shorter than the second one that I drew. Has to. Okay, so you do have to remember that, though. They do bisect each other, but they're not equal to each other, I guess, as I could stop there. Okay, again, there's nothing exciting about this. It's just really based on definitions and knowing. Okay, I think we know what a rectangle is. Okay, all angles are equal to 90 degrees. Who do we got here? Oh, okay. Did you pass? All right. Okay, good. But was it on were these or no? Was it these or no? Okay, thank you. Yeah, I'll add that to the. But what I'm saying is, were some of the questions repetitive? See you later. All right. 90 degree, 90 degrees, 90 degrees, 90 degrees. Man, I'm struggling writing right now. Okay. And this is what we got to do. I am not going to mark this up like a parallelogram. So what we have to understand is a rectangle is a parallelogram, so it has all the markings of that previous picture. We're just going to add the new stuff. All right. So obviously we know the two opposite sides are congruent. The two top and bottom ones are congruent, but not all 4 are. All angles are right. I've already marked that. Here's the difference. And I think you could make common sense out of this. These diagonals, since this is not slanted, that's the same distance from corner to corner that is. So these are equal to each other. How do we mark that? 1, 1, 1, 1. All 4 of those segments are equal to each other. The full diagonal and then each little portion, since that corresponds to the previous parallelograms where the diagonals bisect each other. That's what I was kind of getting at. So what we're trying to do is get this down to the brass tacks. What is really what I need to know there? Don't know anything about these angle measures. Of course, in between these add up to 180 because they're straight angles. That's how you start solving stuff when you get into those things. So now imagine we're going to have some, this is going to move on from grade school stuff when we incorporate trigonometry, maybe to find a side measure from an angle measure, or 45, 45, 90, 30, 60, 90 stuff. So you're going to have to remember that stuff as we move on. And that's why we kind of throw that in each chapter since that. It's almost a little review into the new stuff. All right. So hopefully that's good. Are you okay over there? All right, next one. Parallelograms that are a rhombus. That means all 4 sides are equal. Now I'll just stick with blue. I don't care about the colors. All right. So again, a rhombus is a parallelogram. So I could mark it with all the parallelogram properties as well, but this is a little different. All 4 sides are equal, so we will mark them as equal. All sides are congruent. Got that. Okay, now you want to get nuts. Let's get nuts. First of all, again, I think you can see that these are slanted. So that is going to be shorter than that one. So the diagonals are not equal to each other because of the slanting of this rhombus. Those corners are farther away. The second one I drew from bottom to top. But what they do is they're very, very special. All right. And it kind of looks like it. I don't know what else to say. You're just going to have this memorized. They are actually perpendicular to each other. So and you'll see this in all of them. In all of these, when I draw the diagonals, the quadrilateral becomes 4 triangles. Hopefully you see that. Now you have 4 right triangles. All right. And also what you have is these bisect each other. So that's 2, that's 2. This is 3, this is 3. That means they're not equal all the way around, but they do bisect each other and they're perpendicular bisectors of each other. The bisecting's not new. That is what all parallelograms have for that. So I almost don't have to write perpendicular bisectors, but that's a repetitiveness of And then one more thing. Opposite angles are congruent, so these diagonals also bisect these angles. So 1, 1, 1, 1 mark. All 4 of those little angles are equal to each other. A, because opposite angles are equal. B, the diagonals in a rhombus bisect those angles. So now I can mark all 4 of those as equal, and then all 4 of these as equal. So again, there's nothing special I can do about this other than to express it to you. The only other way we could prove this is actually draw a rhombus with 4 equal sides and then measure the angles with a protractor. I had to figure out which one was right. Compass, remember? All right, anyway, the protractor measures the angles. Did he say a bad word? All right, anyway, is everyone okay out there? There is a class in here. They're just super quiet today, and they're sweating. It's like a sauna in here. Who thinks it's too warm in here? Raise your hand. Oof, wore these because I'm getting ready to freeze my butt off in the baseball game. I'm just waiting for it to be canceled. We're gonna be halfway down. Game's canceled. Okay, and then we got a square. All right, all 4 sides are equal and 90 degrees. So we know that. Come on. You know what, though? I'm not even going to put those because it's actually, here's what's special about this. All properties of a rectangle and a rhombus. So I really didn't have to put those 4 equal sides. Here's what you really want to draw, the new special thing. Obviously, this diagonal is equal to that one. I think that's common sense. If this is a rhombus, that's right. If this was a right angle and this also bisects, then these are 45, 45, 90s. So I'm not going to mark them as equal. I'm going to mark them as exactly what those measures are. And then you can imagine all the way around, I have 3 or 4, 45, 45, 90. So if I'm given a diagonal, I can find all the sides through A root. Anyone? A root 2. How did they know that? Because they memorize and they do their homework. Blah. That's why. So I'm just stalling. Let them put that all in. So at the end, I'll wait till we do the tree of things. This is not going to go to the whole period, so we'll go pretty fast. I know you have to write, though. But that's the end of one family tree of quadrilaterals. Notice I said a parallelogram leads to a rhombus or rectangle, which those are parallelograms. And then when you put a rhombus and a rectangle together, you get a square. So a square is a rhombus. All right. And then those are the kind of questions I'm going to talk about here about you get always, sometimes, never questions. I'll wait till the tree is done. So now here's another branch. A trapezoid is not a parallelogram. So a trapezoid is a separate branch of quadrilateral. So you'll see that when we do our little tree diagram at the bottom of our notes. A trapezoid only has one set of parallel sides. Then I had to add this because I threw this in the next one, isosceles trapezoid, but it's definitely true in a trapezoid. Same thing. You have, I guess I use my mouse here. And I'm tethered sitting at my desk because new technology. I can't connect wirelessly. I think I said that, but these are same side interior angles again. So here we go. 2 parallel lines cut by a transversal. Same side interior angles would be supplementary. Same thing. 2 sides that are parallel cut by a transversal. If that's the case, same side interior angles are supplementary. There's no relationship with A and B and no relationship with D and C. Oh, except this. I forgot. We should put this all the way at the top. What's the sum of all 4 angles in any quadrilateral, everyone? 3, 2, 1, go. 360. So all the angles should add up to 360 in all of these quadrilaterals, all right? No matter what. Obviously, square 90, 90, 90, 90, rectangle 90, 90, 90, 90. Those add up to 360. Any quadrilateral, they add up to 360. That's a general idea. All right, and then the next ones, I kind of get lazy and the drawings are drawn. But do you go to the next page now? I just gave you some space to write. Okay, let's go. Sorry, that's last. We should go to isosceles trapezoid next. Okay, now we got something special. And sorry for maybe I'll mark them as I go for the video. Okay, let's get rid of all that. Okay, so non-parallel sides are congruent. So the legs are congruent. So if I have an isosceles trapezoid, these are parallel, but now these are congruent. Think of a an isosceles triangle. When an isosceles triangle happens, then obviously these angles opposite those two sides are equal. But then so are these. Wrong, 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 wrong. I hit something in my brain. These are equal. Both upper base are equal and lower base angles are equal. So a similar relationship. Lower base angles and upper base angles are congruent. I separate that into two separate sentences. Feel free to put that in one. That's the idea of isosceles. Sides are equal, and then base angles are equal to each other. If you want to color code it better, that's fine. I'm going to color code for my diagonals. Now, I think it should be common sense that these diagonals are equal to each other because of the isosceles nature. So, I got to draw that again. My hand was in the way to draw that straighter. Go this way. Still probably not going to be the best. Yeah. A little shaky, Mr. Samuelus. So not only are the diagonals equal, I'll put this and then I'll zoom back here. Diagonals are congruent. I guess that's it. Yeah. But what I can do is this, and this may be something we can mark this way. What we can do for these diagonals is mark them in a way that they're congruent, but also these parts are congruent. So this part will be congruent to that part, and that part will be congruent to that part. And then the whole diagonal is equal to the whole diagonal. So there's no bisection, but they do cut them into what I would guess call proportional parts, if that would be a word I could use. That's definitely true. So that's why we can go into the diagonals being congruent and mark this a little bit better to show even more parts are congruent. No right angle on those diagonals. They're not perpendicular to each other. And the same idea. This is because they are same side interior angles. An upper base angle is supplementary to a lower base angle if the parallel lines are above and below each other. They don't have to be. They could be like this, but we have the drawing like that. So an upper base angle is supplementary to a lower base angle. Same side interior angles. Everyone okay? Go fly a kite. Has anyone ever done that? Raise your hand. Have you done the old-fashioned ones where you get the real cheap one, you get the wood sticks and you got to put them in the so the actual kite like this? Yes, yes. Okay, they're like a buck. I feel like they're super cheap. So here is a kite, and I guess I'll erase this so that you can see this live in the movie. Oh no, all those beautiful parts here. Now, a kite is not a trapezoid. There is no parallel line anywhere. And I think you can look at this. This is truly a kite. The assumption is, well, it looks like this side is certainly equal to that side, and this one is equal to that one. And you'd be right. That's why I think assumptions can actually help you on this. You don't have to memorize. So two disjoint consecutive sides are congruent. I guess that's what the word disjoint means. I don't know. But it's not all four sides are equal. That's what a kite is. One, whoa, right? One's rubber band out much farther than the other. I think you could surmise that this angle could not equal that angle because that one is stretched out even more. But I think you could take a wild guess that these two are equal, and they are. But I'm going to mark this a little differently after I do the diagonals. Let's draw the diagonals first. When I draw these diagonals, number one, I think you know from doing a kite that these are perpendicular to each other. Makes like a little cross, if I'm allowed to say that. And then, so these are perpendicular. And then look at this one that goes up and down. Boy, that certainly looks like that this has been bisected. And it has. So we can mark that as 3 and then write that in word summary. I'm just going to reveal the words. One diagonal, I had to throw that A in there, is the perpendicular bisector of the other. Which one? Make an assumption. The one that looks like is, because the other one certainly does not look like it's bisected. I don't know what else I can tell you. Sometimes it's common sense. One of the diagonals bisects a pair of opposite angles. Well, by golly, if I could use bad words, that looks like that was bisected, and that looks like it was bisected, but they're not equal across the way. But those are the ones that look like they're bisected. The other ones do not. So therefore, those are not. What did I say about two disjoint consecutive sides are congruent? Diagonals. We got something about those opposite angles. One pair of opposite angles are congruent. Who does that look like? It looks like those that I said in the beginning. So how can I mark those? Well, I mark those in green. I guess I'll go red, but now I'm stuck. This really stinks. So this angle, 1, 2, 3, is equal to this angle, 1, 2, 3. And this angle, let's do like a little circle on that, is equal to this angle, circle. This is where the geometry gets a little tough to mark these angles congruent. Or I have a better way. I just know what I did. I know what I had before I drew this. I got it. I'm changing everything. Too late for you. Oh no, I lost my diagonal. I'm sweating profusely right now. I'm going to lose my diagonal again. I'm glad this is on the video. I'm sweating even more because now I'm nervous. Then there was a fumble. All right, so let's put 2 arcs and 1 arc. There you go. That's a better way. Are you okay over here? All right. All right, 2 arcs and then 1 arc. Oh, whew. Okay. So one pair of opposite angles are congruent. And there's your kite. All right, let's get this over with. I felt like I fumbled a little too much on this. Now, right at the bottom of this, do your little tree, your little family tree of quadrilaterals. Here we go. So at the top, right in that open space on your note sheet, what's your family tree of quadrilaterals? Well, I just said we have a set of parallelograms, and then we have things that are not a parallelogram. So we have parallelograms, trapezoids, and a kite is not a trapezoid. Now, if you want to look at your homework real quick, I'll pull that sheet right here. This annoying side that says all, some, or no. Sometimes that's always, sometimes never. Is a kite a trapezoid? Is that a sometimes, never, or always? Never. A kite has no properties that a trapezoid has. Well, there's some similarities, but there's no parallel lines. Is a kite a quadrilateral? Sometimes, always, or never. Always or yes. That's a flat out definitive yes. Is a quadrilateral a kite? Please listen. Is a quadrilateral a kite? Sometimes it could be, but it's not always. If I got a quadrilateral, I could have just about anything, but sometimes it turns into a kite. So that would be a some or sometimes in the classic sense. So that's how you answer the 1 through 20 on the back of your sheet there. Classic, sometimes, always, never questions. And I'm going to keep playing with those as I look at these. Obviously, trapezoid has an isosceles trapezoid below it. Whereas parallelogram, the next 2 family members were rectangles and rhombuses. So, is a rhombus a parallelogram? Sometimes, always, never. Is a rhombus a parallelogram? Sometimes, always, or never. 3, 2, 1, go. Always or yes in the sense of that worksheet. Is a rhombus a rectangle? 3, 2, 1, go. Never. Okay, though that's a no. All right, so you can't go like that way. A rhombus is not a rectangle. They have different. They're both parallelograms, but a rhombus and a rectangle can't be compared. Obviously, is a rhombus a kite? When you go off tree branches, that's a never. Basically, when you go down this way, though, is a parallelogram a rhombus? Let's think about that for a minute. Is a parallelogram a rhombus? 3, 2, 1, go. Sometimes. Okay, because if I have a parallelogram, I could have a rhombus, a rectangle, or even a square. All right, so that's why that's a sometimes. So it gets a little weird. All right, then obviously we know we put the rhombus and rectangle things together, we get a square. Is a square a rhombus? 3, 2, 1, go. Always, because a square has all rhombus properties. Is a rhombus a square? Sometimes. That's how it works when you go up or down the tree branches. It's very simple once you look at that diagram how to answer those questions. That's all I got for you all. I think that's okay. Even though that sheet is 4 pages long, I don't think it's that big of a deal. All right, that's what I need. Stop sharing.